So it's interesting teaching assembly programming to a child. If you remember, the reason I'm making this playlist is because I am teaching this language to my son who wanted to learn how to program, and he has such an interest in it. I felt like let's start him at the bottom, low level, hardcore assembly language, and then work our way up to the more fluffier languages like C# and SQL and that kind of thing. Anyway, don't quote me on that. But it's also challenging to give him problems that I think are rather simple, and then to find him struggling, it opens for good learning opportunities. So regardless of where you're at in your life and whether you know math or not, we're going to do a little bit more math, but then I highly challenge you to work this problem out that I'm about to give you on your own. Right, it took my son literally 5 days to work through this, and me just gently prodding him, which tells me that if you just watch me solve this problem, it won't benefit you at all. You should try to implement this problem yourself. So let's get going. If you remember, or if you don't remember, if you don't know, 3, I can do the syntax with 3. I can say 3 to the 2, and this is what we call a power, and that is basically a shorthand way of saying 3 times 3, or 9, so to say. So if I say 3 to the 5th, that is the same as saying 3 times 3 times 3 times 3 times 3. 5, whoops, 5 3s, which basically, one way you can think of this is 3 times 3, which is 9. This is 3 times 3, which is 9. So that's 9 times 9 is 81. And then 81 times 3, what is 81 times 3? I can't really shoot that off the top of my head. I guess that's 243. All right, 243. Well, basically, the challenge we're going to have is I want to write a program that will add 3 to the 1 plus 3 to the 2 plus 3 to the 3 plus 3 to the 4. You see where I'm going with this? Plus on and on and on up into 3 to the 100. Okay? And I don't care what number you put here. It could be 5, or it could be 10, or 100, or 1,000. I don't care what this upper limit is. I want to write a program that would basically calculate that value for us. So let me stop there. That's where I stopped with my son and say, hey, solve this problem. How would you do it? Pause the video. Actually, don't pause the video. Close your browser and try to solve this problem on your own in assembly language, and then come back and let me talk about the struggles we went through to get an answer to this. Okay, well, first of all, this is kind of a difficult problem to keep all in your head. If you think about it, what's 3 to the 1? Well, 3 to the 1, that's 3, and then 3 to the 2, that's 9, and then 3 to the 3, oh, that's 27, and then what's 27 times 3? That's 81, and then 3 to the 5th, if we had it here, that would be 243, so on and so forth. So the first problem you need to conquer is these powers, all right? We need to get these intermediate values. And then the next problem you need to do is add them all together, which we call the sum. All right, this is the summation, if you would. I believe I've used this symbol before in a previous playlist, but don't worry about it. The sum means we're going to add all of these values. Well, trying to keep track of all these steps and what's going on in the computer, and then also keeping track of that in hexadecimal, I found and I learned with my son that it's better to chart this out and engineer it. Okay, he started to do what all of us do as programmers. We're all guilty of this, especially brand new programmers, but I call it shotgun programming, where you kind of write it out, you think it's going to do it, you're not sure, let's step through, see what it does, and then, oh, well, that didn't work, let's just change this, see what happens, let's just change this. And so every time it's like you're shooting a shotgun, just trying to solve the problem or kill the bird or whatever. It's boom, boom, boom. There's no intelligence to it. You're just trying to thrash away to an answer. Let's not do that. All right, let me draw a diagram that worked well for us. If I can, let's see, I'm looking at a piece of paper here I referenced here. 1, 2, 3, 4 columns. So let's do, there's 1 column, 2 columns, 3 columns, 4 columns. In fact, I'm going to put that over there just to give us some more screen real estate here on the left. And then we'll go like this, and like this, and like this, like this. Like this. How many rows do I have here? I got 1, 2, 3, 4, 5, 6. So let's see, 1, 2, 3, 4, 5. Oh, we need one more. Need one more. This will be 6 down here. Okay, and then all we need to track really is what loop are we on. Okay, the loop is basically the iteration that we're on. Okay, we have 3 to the 1, and then 3 to the 2, and then 3 to the 3, and 3 to the 4, 3 to the 5. All right, so you can see we're going to do the same thing over and over and over again. It's just a matter of telling the computer to do that for us. The next step we need to do is the power, and the power is this exponent here, this 1, 2, 3, 4, 5. And so right here, let's write down the result of this to that power. So 3 to the 1 is 3, 3 to the 2 is 9, 3 to the 3 is 27, 3 to the 4 is 81, and 3 to the 5 is 243. All right, and then as we get all these numbers, I showed you we had 3 to the 1 plus 3 to the 2 plus 3 to the 3, so on and so forth. Well, let's track the sum. We're going to add these as we go along. So 3 to the 1 plus 3 to the 2 plus 3 to the 3 plus 3 to the 4. Every time we do a loop iteration, which is basically do it again, do it again, do it again. Let's track the sum, all right, the total. All right, the total starts at 0, all right, and we'll call this the total column. Total. And let's see. 0 plus 3 is 3, and then 3 plus 9 is 12. And then 12 plus 27 is 39. 39 plus 81 is 120. And 120 plus 243 is 363. It looks like I'm really good at doing math in my head, when I'm actually just looking at this chart sitting here on my desk. So there you go. You know my magic. And then one other thing we need to keep track of is the debugger will show these values to us in hex. So I think it's simple to say, hey, you know, it'll simplify our life to say what's the hex, what's the total value. Let's convert these values here to hex. Again, go look at the hexadecimal playlist if necessary. So 3 converted to hex is a 3, and 12 converted to hex is a C. I can at least do those in my head. 39 converted to hex is a 2-7. 120 converted to hex is a 7-8. And 363 converted to hex is a 1-6 B. All right, we'll do a capital B. And we'll do a better B than that. That looks like an 8. I bet I can do a better B than that. Here is B. All right, so if our program's correct, we can step through one by one and just make sure that the results we get in the debugger are the same as what we are experiencing here. And if they are, then we can certainly feel comfortable stopping there. So I'm going to show you a little less optimal way of doing it first, because I think it's educational to start out basic and then optimize towards something better, and we'll do just that. First thing we need to do is decide what registers are going to track what values for us. This program's complex enough that thinking EAX and EBX and ECX, it's hard to keep track. Okay, what does EAX mean again? What's ECX? I can't remember. EDX? What are we doing something with? That level of indirection takes up brain cycles. All right, we like variable names like count and sum and that kind of thing. And we certainly could have used RAM if we wanted to, but we're not going to use RAM when we can use a register, because registers are much faster than accessing memory. So we like to use registers as much as possible. But again, going off those names, it takes up brain cycles I don't want to waste. So let's just write down for reference somewhere. I don't know, where should we do it? How about we do it down here at the bottom? Let's say, well, first of all, what do we need to track as the loop goes on? Do we need to, well, pause the video before I tell you. Pause the video, think about it. First of all, we need to track the base. All right, the 3 here is the base. All right, we need to track the sum, the total. All right, and we need to track the power of 3 that we're on. All right, so I guess I should have just drawn these arrows right here. We need to track these 3 things, and we need to decide which registers are going to do that for us. Let's erase this right there. Well, how about we just let's see, power. Let's start out like this. This will be EAX, right? Terrible handwriting. EBX and ECX, and that's how we'll start writing our program. I'll tell you up front, we're going to run into some snags because me and my son ran into some snags, but it's educational, and I'll address those snags as we hit them, and we will realign and readjust when we get there. But for now, I think this video is long enough. I've posed the problem. We have somewhat of an engineered approach to doing it. Let's use that approach to actually write our program.